To solve a quadratic equation like this, the technique is to factorise. Now we could just go straight for the quadratic formula, but it's better to factorise if you can. So we don't have a common factor here with the 3, the -7 and the -6, so we have to look at splitting the middle term. Remember, 3 is A, -7 is B, and -6 is C. The trick is to find the product AC, -18, and the value of B, -7. We need to find two numbers that multiply to give -18 and add to give -7. So I'll just start listing factors of 18. I could have 1 times 18, I could have 2 times 9, 3 times 6, 4 doesn't go evenly, 5 doesn't, and if I start 6 times 3, I'm repeating. So these are the factors I have to work with. Now, as it has to multiply to be -18, one of these must be negative. I also note that the sum of the two numbers has to be -7. So that gives me a bit of a clue here. If I go 1 and -18, 1 plus -18 does not equal -7, that's wrong. 2 and -9, let's try -9. 2 plus -9 is -7. That's the one. This is the pair of numbers we need. So we have 3x squared. We have -6 equals 0. The middle term is going to be split into these two. So positive 2x minus 9x. This is why the two numbers had to add to equal -7, because these two numbers added were the same as -7x. Now we take common factors, but just the first two terms. Well, 3 and 2 have nothing in common. X squared and x, we have a factor of x, leaving 3x plus 2. Now look at the second two terms. I can think of a factor of 3. If I use positive 3, I'll end up with negative terms inside the brackets. Now I want the brackets that form here to be the same as this. So I'll take a -3. -3 as a factor of -9x is 3x. -3 as a factor of -6 leaves positive 2. The brackets are the same. That's what we need. These brackets are now a factor, a common factor of the first and the second term. 3x plus 2, x minus 3 equals 0. Now we use null factor law. 3x plus 2 could equal 0. 3x is -2, or x is -2 on 3. Alternately, x minus 3 could equal 0, in which case x equals 3. We can always check our solution by substituting these back into the original quadratic to see that it evaluates to give 0.